Welcome to video 4. Today we're going to talk about writing and using arithmetic and geometric recursive formulas. So this is the new idea here, is this recursive. The formulas that we have been using up to this point look and work a lot like the functions that we have learned this year. But sometimes we'll have formulas that only give us the pattern that we can use to make this sequence. So using this idea of if I only know a sub 1 is 4 and that there's a common difference that can help me get to the next terms, we'll use this to find the first 3 terms. So when I write that out, that would mean that I would start with the 4. Then we would need to add 7 each time. So 4 plus 7 would be our 11, plus 7 would be 18. And they said just find the next 3 terms, so one more 18 plus 7 would give us the 25. Why is this so tough to find a sub 25? Well, if all I'm given is this whole information of, oh, well, I can add 7 every time, then I would just have to add 7 all the way out until I hit 25, and I would have a very long list of numbers, and it would take a lot of time to write all that out and just add 7 each time. So the formula for this sequence that we just talked about is a sub 1 equals 4, and then a sub n equals a sub n minus 1 plus 7. So this a sub n minus 1 is the new idea here, and that just tells us the previous term. So anything like that just means previous term. The formula that we just looked at gives the first term a sub 1, which we've already been using, and a formula for finding any nth term using that a sub n. In the formula, you are always given what you do to the previous term, a sub n minus 1. So this type of formula is called recursive. And as I said, they can take a little longer. You have to have the previous term in order to find the next one. So that makes it a little harder to go ahead and list out and find big numbers. When using a recursive formula, you will need a starting value. Usually it's the first term, a sub 1. The formula used to find the remaining terms. In this formula line, you want to locate the previous term notation, however they're writing previous term, circle it and mark it with PT for previous term. Then you'll set up the terms you are finding by replacing the circled previous term expression with a set of parentheses. And then inside the parentheses, you will put the previous output to get your new answer. So what previous term notation might look like? If the formula starts with a sub n, then the previous term would be notated as a sub n minus 1. Because if you think about if it's a sub n, then the one that came before would be a sub n minus 1. This one's different because it's saying a sub n plus 1 as the previous term. Well, if it's a sub n plus 1, then we would use a sub n as the previous term. So it's just saying the one that came before. So if it's a sub n plus 1, then before that would be a sub n. They can also show these using function notations, so like f of n and f of n minus 1, or f of n plus 1, and then f of n. Just the same idea using function notation. Okay, let's look at an example. Considering the recursive defined sequence a sub n equals 3 times a sub n minus 1 with a sub 1 equal to 2, what type of sequence is it and why? To answer that, we have to look at the equation that we're given. We're given this 3 times a sub n minus 1, which is previous term. So 3 times means it's a common ratio, so that would tell us that it's a geometric sequence. So it's a geometric sequence because there's a common ratio shown with a multiplication by 3 to the previous term. So that whole times 3 each time is what tells us it's geometric. Now, if they want us to determine a sub 4, so in order to find a sub 4, I would need the previous term, which would be a sub 3. But to find a sub 3, I need a sub 2, and that keeps going backwards. So I'm going to write out the a sub 1 equals 2 first. Now I'll try to find a sub 2. So when we look at, remember I'm going to put that PT above previous term, and I'm going to replace it with parentheses in my equation. Then in place of the parentheses, I'll put the previous term. So the previous term here was the one that came before, so that would be the 2. That's the a sub 1, the previous term. So that goes in the parentheses. So I've replaced the previous term with 2. Then 3 times 2 gives me 6. So that term, the second term, was 6. Now I'm going to do the same idea. I opened up my parentheses. In those parentheses, I'm going to put the previous term, which was the 6. That gives me my third term, and now I can do the same thing for the fourth term. So I've opened up those parentheses, and then in those parentheses, I'll fill in the previous term, which was 18. So that tells me my fourth term is 54, and then that's the answer to my question. Okay, we'll pick up with this tomorrow. Have a good night.